So the next component is the RTC board, and in a pattern that I'm sure is familiar to everybody now, we first kick off some unnecessary resistors. The first one is the limit resistor for the power LED. Again, just basically a waste of energy for nothing on an data logger.
That's because it's inside a housing deployed somewhere. There's no one to see it.
Well, you could technically still see it. It's just that it doesn't do anything useful for us. So there's the limit resistor. And this particular RTC board has a really nasty charging circuit. Doesn't really do anything. Doesn't even operate when you're using a 3.3 volt Arduino because of the voltage of the CR2032 coin cell that goes there. So we just get rid of this because it's not only a time waster and a power waster, it's actually somewhat dangerous. It doesn't serve any purpose whatsoever. So that's the charging circuit, disconnected by just kicking off an SMD resistor.
So we're using lithium coin cells, but some people use rechargeable batteries in these for other applications?
Yeah, sometimes they ship with a rechargeable battery, but the charging circuit is so bad that even if you were using it on a 5 volt Arduino where that charging circuit could function, I don't trust it. It's a really badly designed charging circuit.
And with the Cave Pro loggers, I mean, the lithium batteries have been running for years and years for the RTCs.
Yeah, for those I do a slightly different trick. I leave this circuit in place and I parallel it with another diode from the RTC post so that the line voltage supplies battery backup. It's a little more complicated. I talk about that with some of the previous video series. We're not going to do that for the student builds because it involves some tricky soldering. I might even have, give me a second here. Aha, okay, so here's one with that modification where I actually have a parallel circuit in play. The VCC line has been grounded and now it's only receiving power from the battery line, but that power is being supplied from the main line. This is a good power saving technique. There's a whole video about it in the previous series, but it is an advanced soldering job. As you can see, we're lifting a pin, we're soldering directly. I don't usually have the students work on that level of soldering. This is kind of an advanced mod, but it will save you almost a tenth of a milliamp on your eventual data logger. But for this build, we're just going to use the standard. We just disconnect the charging circuit, and we're going to put a non-rechargeable CR2032 in there. The next step is to tin those pins and add some jumper wires to it. Same as we did for the SD module. Just apply just a touch of flux. We don't actually connect anything to the 32K wire, but we could later. Some sensors might have use, or we might try some fancy programming techniques that could use that. But for now, the 32K frequency out, I'm just going to tin it, but I won't actually be attaching anything to it. What I will be attaching, though, is wires to all the other pins. And in a sort of cooking show trick, I've already got a set here that have been stripped and tinned, ready to go. So we'll just get those connected. The alarm signal from this RTC comes out on the SQW line, and I usually use blue. Again, just a habit of mine. There's no particular rules about colors for these things, but I do stick to my color pattern for the I2C bus, which is the clock line, the SDA, VCC, and ground. So I always use yellow for my clock lines. And white for my data.
Red for VCC.
Yeah, which is 3 volts on a Pro Mini.
And then black for ground.
Yeah. The red and black are the North American standards, but if you go to other countries, there will be other colors used for those two. excess if I've got any. Alright, so now we've got jumpers set for that end of the board. That's the side that's going to go to the screw terminals on the logger. And now we're going to put a set of screw terminals right on the RTC board. And again, this is an idea that I picked up from Brian Davis. He's rather good at improving on the original design. If you buy these little four-pack screw terminals, this one, they do sell them in the size that will actually go right into the pins, which makes this job really easy. And since I2C devices or bus devices, you can basically hook a sensor right to that without doing very much work. Tack down the screw terminal. It sort of holds itself in place really nicely, which is good. And again, I do the ends first and then the middle. That's just force of habit at this point, but it does help quite a bit. Okay, just checking that I haven't accidentally bridged anything, the plastic hasn't been melted, and there's my contacts. The next step, after removing the resistors, adding our jumper wires and a screw terminal board, is to clean everything. These RTCs are usually particularly bad for solder flux being left around the pins. I don't know if you can catch the reflection there, but there's a huge blob of it there, there's a bunch there, and I'm basically just going to try and clean off the whole board. It's the one drawback. I really like these little RTC boards. Once you get rid of that charging circuit, they're quite nice, but they're made poorly. They're just covered with flux. The thing that's a bit challenging about that is that it's an RTC with an oscillator circuit, so you can't really safely put them into an ultrasonic bath, which is what you would ideally want to do with a board like this. So you're kind of stuck with the old manual cleaning.
Did you clean? Did you clean also where the wires have been put on the pins?
Yep.
Everything.
Basically anything you've soldered, you clean. That's kind of how it goes. Alright, so there's our RTC board ready for some conformal coating. I'm going to give it a quick coat and let that dry and then apply some tape. So there'll be a little gap in the footage here while we let this dry, because this is one I don't want to do in a hurry. I want this one done correctly. I cover all the chips on the board, especially these connections from the DS3231 itself. Now I'll let that dry. Ideally, again, this should be done in a fume hood, because this is really nasty stuff. Alright, once the conformals set, you'll have sort of a very shiny surface left on there, but it's okay for the double-sided tape. We're going to put a couple of layers on that, and that'll allow us to adhere the RTC to the inside of our logger housing. So just throw a few layers of tape. Usually I keep my leftover tape on the roll itself, and that gives me a chance to use the offcuts. The little tiny pieces come in handy for things like leveling when you're gluing things together with tape. You end up with situations like this. This one has a tiny little chip beside a big fat one, so if I put another layer over the tiny chip, it brings it up to the same surface height. So I usually put a little square over the EEPROM. Okay, and then another square much larger over the entire surface there. Okay, so that layer of tape is going to hold the RTC into the logger, and I'm going to put another piece across here, which we have lots of excess for. And again, that will be the second contact point when this gets glued into the housing.
It also helps prevent short circuits and
Well,
contacts.
we should probably put another layer on the top, because it'll be this side up, but it's so out of the way I'm not too worried about it. And we have conformal coating on these exposed pins here, so I don't usually have to worry too much about that. This is really just for, sticking the RTC down, and you want it stuck down so that the backup coin cell is easily accessible inside the machine when it's done, because you'll have to replace that once in a while. Not very often, but because it's the only source of backup power, you could basically need to replace that battery somewhere on the order of about once every 3 or 4 years. So that's our completed RTC module ready for the assembly stage.